Welcome to The Weird Way Space Changes Your Voice, a fascinating journey into the science behind how astronauts sound in orbit. We'll explore the subtle yet profound transformations their voices undergo, far from the familiar sounds of Earth. Have you ever noticed that astronauts' voices often sound a bit different, perhaps a little nasal or even slightly robotic? It's not just the radio transmission causing this. The unique environment of space itself profoundly changes how the human voice works and is perceived.
Behind every question lies discovery. I'm Seluna, and this is SciCurious, where we uncover the science shaping our world.
When the first astronauts spoke from orbit, engineers initially attributed the odd tone and quality of their voices to primitive or faulty radio equipment. They believed that technological limitations were the sole cause of these unusual vocal characteristics. However, as technology advanced and communication systems improved, later missions confirmed a surprising truth. Even with perfect audio recordings and state-of-the-art equipment, astronauts' voices change the very moment they enter the microgravity environment of space. The real, underlying reason for this vocal transformation isn't found within the microphones, communication systems, or even the radio waves. Instead, it lies deep inside the astronauts' bodies, specifically in how their physiology adapts to the absence of gravity. On Earth, gravity plays a crucial, often overlooked, role in our vocal production. It naturally pulls air and fluids downward, creating essential pressure differences within our bodies that are fundamental to how our lungs and vocal cords function efficiently. Remove gravity from this intricate equation, and the entire sound-producing system within the human body behaves in a completely different and unexpected way. This fundamental change in physics directly impacts vocal mechanics. In the microgravity environment of space, without the constant downward pull of gravity, bodily fluids and air distribute much more evenly throughout the chest and upper body. This redistribution has significant consequences for vocalization. This fluid shift causes blood to move upward towards the head and chest, the torso to compress slightly, and the airways to become noticeably more congested. These physiological changes directly impact the mechanics of sound production. This increased congestion in the nasal passages and throat significantly alters the natural resonance of the voice. It's much like the familiar experience of talking with a mild cold, which often makes your voice sound distinctly nasal and muffled. Beyond the congestion, the vocal cords themselves also vibrate differently in microgravity. Without the gravitational gradient to assist the mechanics of breathing and vocal cord tension, their movement becomes less efficient and altered. As a result, airflow through the vocal cords becomes smoother, but also weaker, and the pressure waves generated carry less variation. This leads to a flattening of both pitch and emotional inflection in the astronaut's voice. Detailed measurements conducted on the International Space Station reveal specific acoustic changes. Fundamental frequencies drop slightly, high-frequency harmonics dampen significantly, and the voice loses its usual bass richness and depth. It's as if the microgravity environment subtly tunes everyone's voice toward a calmer, more compressed, and almost monotone sound. The vibrant nuances of human speech are noticeably diminished. Then, we add the additional layer of transmission effects, radio compression, digital filtering, and the unique acoustic properties of a small, enclosed metal cabin. Each of these factors further modifies the voice before it reaches Earth. Together, these combined factors, from physiological changes to communication technology, contribute to making astronauts sound halfway between a human voice and a synthesized machine. It's a truly unique auditory experience. Despite these profound vocal changes and the challenges of communication, astronauts still find remarkable ways to express themselves, even through the universal language of song, bringing a touch of humanity to the void. Fun fact, NASA acousticians meticulously model the International Space Station's complex soundscape. They do this to predict precisely how voices will carry and be heard amidst the constant hum of fans, pumps, and ventilation systems that keep the station operational. Without that ever-present background hum, conversations within the ISS would feel eerily silent and strangely unnatural. This creates a fascinating paradox in the otherwise noisy and bustling environment of space. The ISS itself is surprisingly loud, with internal noise levels typically ranging from 60 to 70 decibels due to the continuous operation of its essential life support equipment. This is comparable to a busy office or a loud conversation. This constant background noise means astronauts must speak louder than normal to be heard clearly. This extra vocal effort can make their voices sound even more strained and fatigued over time. In microgravity, you don't just feel weightless. Your voice experiences this profound absence of gravity too. Every aspect of vocal production is subtly, yet significantly, altered by this unique physical state. The sound you produce carries indelible traces of your immediate environment, the atmospheric pressure, the subtle pull of gravity, and even the constant hum of the machines that sustain life around you. It's a profound reminder that sound is fundamentally physical. Its very existence and characteristics depend entirely on the intricate physical properties and conditions of the world around you. So, does space really change your voice, where breath has to learn to flow in entirely new ways? Absolutely. It's not just a minor alteration, it's a complete physiological adaptation. It's your body adjusting to a new kind of physics, a fascinating and complex adaptation to the cosmic frontier. This vocal transformation is just one of many wonders of human resilience in space. Curious for more scientific explorations and amazing discoveries from the universe and beyond? Stay tuned with SciCurious for our next deep dive into the wonders of science.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.